Hello, ladies and gentlemen, and welcome back. Root Beer here with question number 3 on the Euclid paper. That's the Euclid paper from 2004. So we got a light bulb question followed by a written question, and things are getting a little tighter on the contest. I would expect more so than previously. Like for the last question, there were some lines, and it was vaguely the theme of lines and understanding slope and y-intercept, but I would expect more and more for the questions to sort of have to do with one another. So I'm reading just the first little bit of our light bulb, an arithmetic sequence. I would expect an arithmetic sequence maybe to show up in B part. Okay, so I start thinking of all the things that can be done with arithmetic sequences. But let's actually get into it and read the question. In an arithmetic sequence with 5 terms, the sum of the first 2 terms is 2, and the sum of the last 2 terms is negative 18. What is the third term of this sequence? And then, for people who don't know, because this isn't really taught that much in school, an arithmetic sequence is a sequence in which each term after the first is obtained from the previous term by adding a constant. For example, 3, 5, 7, 9, 11 is an arithmetic sequence with 5 terms. They have a common difference of 2 between each term. So we add 2 to get every subsequent term. Okay. What are we to do? Well, in general, each arithmetic sequence can be written in terms of A, the first term, and D, what's called the common difference. Okay, so the first term is A, and then to get the next term we add on D. To get the next term we add on another D. To get the next term we add on another D. And we're only dealing with 5 terms, so we'll just leave it there. Although in general, if I may just write over here, in general the nth term is A plus n minus 1d. There's a great formula for adding these up. Maybe we'll get to that at some point, but there's a lot of little stuff you can do with arithmetic sequences. But we only need 5 terms, so here we go. We don't know A, we don't know D. This is as general as we can make it, but we are told what? The sum of the first 2 terms is 2, and the sum of the last 2 terms is 18. What is the third term in the sequence? So it might not be possible to actually work out what A and D are, but maybe it sort of forces A plus 2D to be something. Maybe. Alright, so 2 is A plus D, or rather 2A plus D. Negative 18, that's the sum of the last 2, that's A plus 3D plus A plus 4D. And that's going to be 2A plus 7D. Okay. So, well, you actually can, if you want to, work out what A and D are, and I'll do that in a moment, because I imagine some people out there will have done that. But if just for a moment we take a look at these, 2A plus D, 2A plus 7D, if I add those up, I'll get 4A plus 8D, but that's 4 times A plus 2D. Well, this is 2 plus negative 18, so that's negative 16. And if I divide that by 4 and get negative 4, that will be A plus 2D. And since it's a light bulb question, this is all I need to do. A plus 2D is negative 4. I don't actually need to know what A and D are. And this is sort of a common thing that happens from time to time when you have sequences or a bunch of equations on Waterloo contests, is sometimes, although rarely, you can't get any of the individual numbers, but you can get the thing they're asking for. More commonly, however, there's a shortcut, like we've got here, to just get A plus 2D without any understanding of what A and D are. And then there's a long way around, which I'll show you now, which is work out what a is, work out what d is, and then combine them to get a plus 2d. Little time saver things for people who have practice, people who are in the know, people who understand arithmetic sequences, but still a long way around so the contest is accessible in case this is the first time you're doing this sort of thing. Okay? So instead what we can do is we can say, all right, 2 is 2a plus d, negative 18 is 2a plus 7d. So I can call this equation 1, equation 2. I can do equation 2 minus equation 1, and that's going to get rid of these 2a's, and that'll be 7d minus d, or 6d. And equation 2, that's negative 18 minus another 2, that's going to be negative 20. So 6d is negative 20. I can at least do 3d is negative 10. D is negative 10 over 3. Okay, not the nicest of numbers, and actually such a weird looking fraction that I might even be inclined to believe that I might have made an error. And that, because I would have expected a whole number here, just mathematician's intuition here. Okay, but now I can take this d and plug it back in. 2 is 2a plus d, well that's minus 10 over 3. So 2a is 2 plus 10 over 3, so that's 6 plus 10 all over 3, so that's 16 thirds. Divide by 2, a is 8 thirds. Okay. If we wanted to double check, yeah, does this work? 18 is 2 times 8 over 3 plus 7, negative 10 over 3, so that'll be 16 over 3. Minus 70 over 3. 16 minus 70 is 54. Negative 54 over 3. And yeah, that's negative 18. So it does check out. And our third term is a plus 2d. So that's 8 over 3 plus 2 times negative 10 over 3. So that'll be 8 minus 20 all over 3. But that's negative 12 over 3, so we get negative 4. Just as we did on the previous page when we did the shortcut. Okay, we could have just divided by 4 and everything's fine. That was a nice quick shortcut, and it actually avoided these fractions that even made me second guess myself. But however you did it, minus 4 is our answer. Okay, and it's a light bulb, so if you just wanted to jump to that, everything's fine. But we've explained it. We've actually explained it 2 ways, which you shouldn't do in a contest. Pick one way and stick to it. I do multiple ways to show you different ways of doing things, you know, maybe to educate you a little bit. But stick to one way. You don't want to confuse people. Okay, but however you did it, minus 4, and if you just wanted to write minus 4, it's a light bulb, so that's fine. But showing a little bit of work can help. Okay, so that was A part. We still have our good friend B, which needs to be written. Okay. If x minus y is 4 root 2, and xy is 56, determine the 2 possible values of x plus y. Ooh, okay. So, what have we got here? Whoop. Well, let's write down these equations here. X minus y is 4 root 2. Xy is 56. Okay. How am I supposed to relate these? Well, there's a couple things we could do. One, we could take this first equation and rearrange it to something like x is 4 root 2 y, or plus y. Substitute that in here. But I don't like this 4 root 2 very much. I really don't. So my instincts are get rid of that 4 root 2. The root 2 is what's driving me a little batty. So what I'm going to do is I'm going to square 4 root 2 squared. So 1 squared is the equation we now got. So x minus y squared, 4 root 2 squared. This is going to be 32 over here. And we're going to get x squared minus 2xy plus y squared. Okay. You might say, well, yeah, you got rid of the root 2, but you made this part more of a mess than it needed to be. You're absolutely right. But what do we want? We want x plus y. And they said there are two possible values for x plus y. And you usually get two possible values when you're solving some sort of quadratic, some sort of square thing. And if you had rearranged and said, you know, x is 4 root 2 plus y, and substituted that in, you would get, if you substituted that into 2, you would get a quadratic equation. It would just have a pesky 4 root 2 in there. We don't like that. Because we don't care what, say, x or y are. We care about x plus y. So x plus y, if I squared that, and this is really just coming from experience, I see this equation, I know what xy is, I can very quickly turn it into this equation by adding on 4 xy's. Square root it, I'll get the two possible values of x plus y. And they didn't care what x and y were. Just like in the last question, they didn't actually care what a and d were. So here's what I'm going to do. I'm going to add on 4xy. So that's adding on 4 times 56. What is 4 times 56? I'm not going to try and do that one in my head, because I've got a calculator. Why not use it? 224. Okay. So, now if I add on 4 of these, the x squared stays where he is, the y squared stays where he is. But negative 2 plus 4 is positive 2. And now 32 plus 224, that's going to be a 6, a 5, a 2. Hey, I recognize this number. It's 16 squared. So the two possible values, x plus y, could be plus or minus the square root of 256. That's plus or minus 16. I don't know what x is, I don't know what y is, and I don't care. X plus y could be 16 or negative 16. You see, we've shown our work without even really having to explain a whole lot of what we're doing. Okay? We took an equation, we squared it. We didn't have to say, gee, I don't like the square root 2. You don't have to explain that. You can if you're being a little fun. But we didn't have to do anything. We got that, and then we added on the 4x plus y. It can look like random inspiration when we're writing it up. We just need to explain what exactly are we doing. That plus that equation, and we worked out the 224, we get 256, and then we recognize, there it is, no words at all until our final statement there. And that is exactly what they're asking for. Determine the two possible values of x plus y. So things that I notice in here, because it's quite an insubstantial question, very, very little writing, especially compared to A part. Things that drew me to maybe dealing with squares, two possible values tells me I should be solving a quadratic or something equivalent, and x plus y squared is certainly sort of equivalent. You do get two answers out from that. Other things that drew my eye, x plus y, x minus 4, or sorry, x plus y, x minus y. Y certainly is not going to be 4, I don't think. But x plus y and x minus y and the xy, I've seen this sort of trick enough times to know when you square x minus y, that's only 4xy's away from squaring x plus y. And the thing that really sealed it for me was this root 2. I don't want to be solving for x or y in terms of the other with this root 2 hanging about and subbing it into this equation. Yes, you'll get a quadratic, and yes, you will likely be able to solve that in some way, but it's going to be really icky. It's going to be really unnecessary. There's going to be square root 2's floating around or anything like that. And then you'll have to solve for the other one, y. If you solve for x first, then you have to solve for y, and that will have some root 2's. And obviously, eventually, everything will cancel out, and you'll either get negative 16 or 16. But it would just be so much more work, and so much... what's the word I want to say? the page would be very busy with a bunch of root 2's and what I consider to sort of be inelegant calculations or ugly calculations. Whereas you can see the method that I chose to use, square it, add on 4 times xy, square root it, we're done. We don't care what x is, we don't care what y is. Okay? We just want x plus y, and however we get there is fine. Alright, so that's enough for question number 3. We're going to look at question number 4, but that'll be in the next video. So thanks for watching.